So next up we are going to consider the Koch snowflake, and the beginning iteration is just an equilateral triangle, and then what you do is you replace each side of that by adding another smaller equilateral triangle onto it. And then you do that again for each of the remaining sides, added smaller equilateral triangle on there. So each segment like this gets replaced with this, where this is an equilateral triangle. Turns out that this has finite area, and that's because you can put it inside a circle of finite radius. It's got finite area, but it's got infinite length. So if you do this infinitely many times, infinitely many replacements, it's got infinite length. So we'll look at that again in just a second. Let's first find the fractal dimension. So remember that d is going to be the log of n, cap n, the number of places that we replace, divided by the log of the reciprocal of the magnification factor. So 1 over p. So n here, so we've got one piece that gets replaced with 1, 2, 3, 4 pieces. So n is equal to 4. And then if this beginning side length is side 1, then this will be actually 1/3 right here. And then another 1/3 and another 1/3. So your magnification factor, P, is 1/3. So this is going to be log of 4 divided by log of reciprocal 1/3, so log of 3. And if you compute that on the calculator, log 4 over log 3 is 1.26. So again, we've got fractional dimension. The fractional dimension of this curve, if you keep that process going infinitely many times, is between a line and a two-dimensional space, two-dimensional area. Let's look at what the area of this would be and then what the length would be. So first let's look at perimeter. Let's say this has side length 1. So it's equilateral triangle with side length 1. Then the perimeter of that first iteration, let's call that P0 to be consistent with the notes, is 1. And then notice that P1, the perimeter of this is n equal 1, and n equal 2, and n equals 0. So the perimeter of the second piece, perimeter of the second iteration, well, each one of these sides of length 1 gets replaced with 1, 2, 3, 4 pieces of length 1/3. So this is going to be, each side is 4/3 of its original length. So the perimeter of this piece is going to be 4/3. This perimeter is 1, 1, and 1. That's perimeter 3. Sorry about that. And then perimeter 1 is going to be 4/3 times 3, which is 4. And then the perimeter at n equals 2 here is going to be 4/3 of what it was before. So this is going to be 4/3 of perimeter at level 1. And then what you want to show in the homework, you want to show that this sequence approaches infinity. So you want to try to write a formula for P sub n. What does that equal? And then take a limit of it. Now what about area? Well, the area at stage 0, area is 1/2 base times height. So if we drop a perpendicular here, base of our triangle is 1. So A0 is going to be 1/2 times our base is 1. And then our height, right there, h, well, this is length 1/2. So if you do h squared plus 1/2 squared equals 1 squared, so your height is 1 squared minus 1/2 squared. And if you solve that, you'll get √3 over 2. So that's our height, √3 over 2. And then we're going to add on for A1 here, for the area of part 1, we're going to take that √3 over 4, And then we are going to add on 1, 2, 3 rectangles. I'm sorry, 3 triangles. And then each one of them this is a side length of 1/3. And this is 1/3, this is 1/3. So it's going to have 1/3 the base and 1/3 the height. So we're adding on 3 triangles, and their area is going to be 1/2 times our new base. Instead of 1, it's 1/3. And then our new height, instead of √3/2, it's going to be √3/6. So I took the height and multiplied by 1/3. Well, notice that this is just 3 times our original 1/2 times 1 times √3/2. 1/2 times 1 times √3/2. And then the 1 got multiplied by 1/3 because the new base is 1/3 as long. And the new height was the old height, √3/2 times 1/3. So times 1/9. So this 1/9 is saying that the area of these smaller triangles is 1/9 of the area of the bigger ones. And then for the next step, you're going to add on 2, 4, 6, 8, 10, 12. So you're adding on 12 triangles. And again, these smaller triangles, base and height, are each 1/3 of the previous level. So that's 1/9 of the area of the previous. So we're going to take that original area of, that was A0 here is √3/4. And we're going to multiply it by 1/9 and then 1/9 again. So times 1/9 squared. And you can keep this process going here. And we want to know, well, what happens in general? What's going on in general? So, this is actually the area. The first one would stop here, and then A2 would stop here. So I'm actually writing an expression for A sub n in terms of the original area. So we've got that √3/4 plus, and then we've got 3 times √3/4 times 1/9. And then we've got 3, and to get up to 4 you needed, or to get up to 12 you need to multiply by 4. So this will be plus 3 times 4 times √3/4. And then it was times 1/9 squared. And in the next stage, you're going to have not 3 times 4, but each one of those 12 triangles gets, each one of these guys gets 2 little triangles added on here. So if you look at total number of triangles that are added on, we've got 1, 2, 3 triangles that are this size times 6 groups of 3 is 18, and then times 2, because each one of these 18 little triangles gets 2 added on. So 2 times 18, 36. So this will be plus 36, which is the 3 times, let's see, I think that's right. Oh no, there's actually a little bit more here, because there's a triangle there and there's a triangle there. So if you look at it, each piece here is getting a triangle added to it. We've got 1, 2, 3, 4 pieces there, and 1, 2, 3, 4 pieces there. So that's 8 pieces times 6. 1, 2, 3, 4, 5, 6, 6 groups of 8, 48. Yeah, so not 24, but 48. So that 48 is actually 3 times 16. And then you'll take your original area, root 3 over 4, and then base and height get multiplied by 1/3 again. So that's another factor of 1/9, so that's a 1/9 cubed. And you keep going with that. So in general, we've got this root 3 over 4 plus, and then notice here we've got 1, and then we've got 4 to the first power, 4 squared, and next one will be 4 cubed. So we are going to be summing up powers. Let's see, this root 3 over 4 we can bring on the outside along with this 3, and then we can sum up what we've got left. So we'll have 3 and a root 3 over 4, and then we'll be summing up powers of 4 over powers of 9. So in this term, we've got 4 to the 0 power, 9 to the first. Here we've got 4 to the first power, 9 to the second. So this n, if we start that at 1, this will be n, and then this will be n minus 1, and go up to infinity. And then we'd like these powers to match, so we'll multiply by another 4, and then multiply by another 4 out here. So now you've got 3 root 3 over 16, and now this is a geometric. So this will be root 3 over 2, and then you've got 3 root 3 over 16, and you're summing up 4/9 to the n from 1 to infinity, because you've got 4 to the n here and 9 to the n there. And then that's a geometric sequence, geometric series, excuse me, here. So we can do 1 over 1 minus r for that, and then get an actual area. So what you're showing in the homework, though, is that perimeter is going to infinity.